Hi, everyone. I'd like to welcome you to today's session on material handling equipment battery charging trends. Please remember that this session is also being recorded and will be available to watch on demand following this session. If you have any questions during the session, please add them to the Q&A. You can find that tab to the right of your screen. Note that your questions will be sent privately. With that, I would like to introduce our speakers for today. My name is Akanksha, and I am the Content Marketing Manager at Delta Q Technologies and this session's moderator. Our presenters today are Murad Chargi from Delta Q Technologies and Marco Sabatini from Zevan, which are part of the Zappi group of companies. Murad is a Senior Product Manager at Delta Q Technologies and is responsible for developing and establishing Delta Q's product roadmap. He brings over 25 years of experience in engineering, marketing, and business administration backgrounds to manage the development of new products and industrial battery chargers for electric drive vehicles and equipment OEMs. Marco Sabatini has more than 26 years of experience in the world of chargers, batteries, and electric drive vehicles. At Zevan, he has supervised new product developments, modifications, and customizations to suit any field of application. His strong knowledge on products and solutions across various industries make him a great consultant for any electrification project. So before we commence, I just wanted to go over the agenda before I pass it off to Marco to begin. So in today's session, Marco and Murad will cover regulations and give a market overview of material handling. They will then cover trends in material handling equipment and then go over the battery and charging technology trends. And then we'll wrap up with the key takeaways and a live Q&A session. The main objective of today's session is to gain valuable insights into the latest trends and advancements in material handling electrification, battery, and charging technologies, and to learn how these trends can enhance operations and contribute to environmental responsibility. With that, I would like to welcome our speakers, Marco and Murad, and pass it off to Marco to begin.
Good morning to everyone, or good afternoon. I'm going to start speaking about regulations and market requirements. As you probably know, many countries approved energy consumption limits to the electronic devices. I'm not going to bore you with making a list, but let's say that given the high cost of electricity, energy saving has become a top priority for many organizations. The chargers in general, all electric specifications have been deeply inspected and verified. This study resulted in new rules about chargers that have been adopted by some countries or chosen as standard solutions in many applications and installations. The picture shows an old styled charger and the future of new styled, which can be summarized as high frequency chargers. Summarizing very briefly, if you want to have the best electric efficiency, you have to move to high frequency charger. And even if you want the best input current limit accomplishment, which is the power factor, you have to move to high frequency chargers. The energy conversion efficiency is a mix between hardware and software, and here too you have to move to high frequency, but with better recharge system management. And the standby losses are what is the charger using to stay alive without having a battery, must be managed by a good energy management. With the next slide, I am presenting the California Energy Commission CSC study. They have realized that there is a huge energy loss in the system. This in billion of kilowatt hour is rated. So they have realized that from the electric energy producer to the energy stored in the battery, we just reached 36% of the used power. So the energy companies, which are really taking decisions, and these are the rules that are coming, are forced to produce in excess of 64% of energy that cannot be built completely, and that is anyway a total economic loss. In next slide, I show the picture of the letter that was sent to all the charger manufacturers more than 10 years ago, where CC in California said, listen, we understand you're producing, you're allowed to produce old style charger and finish your stock, but then you have to move to the new technologies, the only ones that we have allowed. And going to the next slide, they have defined really clear limits. They want to have this list of performance parameters. The charger turn factor, they have decreased it from 1.10 to 1.10 instead 1.2, and with a 40% depth of discharge of a battery, which normally with lead acid, you want to allow a bit more of equalization, they have decreased to 1.15. These rules apply to lead acid batteries, but also apply to lithium. With lithium, you have more advantages that later Morad will explain, but in general, the power conversion efficiency, which is the critical point, must be equal or bigger than 89%, and you can reach this only with high-frequency chargers. The power factor must be equal or higher than 90%. The maintenance power mode, which is the amount of energy you use to keep the battery from self-discharging, have this limit in watt, clearly defined and in relation to the energy wattage of the battery. And non-battery mode power is has been reduced to equal or smaller than 10 watts. And Morad now will tell you something about the material handling equipment market.
Thank you, Marco. Considering the market conditions that are explained, some of them that were explained by Marco, let's start by examining some of the current trend in material handling equipment. So, material handling equipment industry have been embracing various technological advancement to enhance productivity, efficiency, and cost effectiveness in warehouse and storage in operations. By adopting and implementing these technologies, plant and warehouse manager can stay ahead of the competition and optimize their operations for success. These are some of the major technological trends shaping the future of material handling. The first one is digitization and what is known in the industry as Internet of Things, or IoT. An IoT-enabled device and sensors and software are being integrated together into forklifts and other material handling equipment. They are enabling real-time tracking and monitoring of inventory and equipment performance. It is a key technology driving current warehouse automation trends. It enables the connection and coordination of all moving pieces in the warehouse environment, and therefore full optimization of procedures. The second trend in the industry is smart warehouses, also known as part of Industry 4.0. Smart houses are equipped with autonomous robot and automated control systems that can perform real-time inventory management, predictive maintenance, and even optimize space utilization. This is resulting in improved efficiency and cost savings. By integrating automated material handling equipment and IoT, artificial intelligence, and data analytics, companies can create interconnected, self-optimized systems that enhance operational visibility and decision-making. The third technology being implemented is goal for high efficiency. And Marco explained a few things related to power efficiencies. So the warehouse work harder and harder to meet the robust e-commerce requests and same-day shipping trends. High efficiency is in demand, and this need will stay there for years to come. Automation and innovative power transmission solutions can optimize workflows with faster pickup, parking, transportation, and inventory. The last trend is the expansion into new industries. As automation becomes more affordable, smaller businesses and industries such as healthcare, pharmaceutical, and agriculture will begin adopting automated material handling equipment solutions, expanding the market reach of the current solutions. These various emerging trends are driving material handling vehicle design, architectures, and operational transformation. Vehicle electrification is not just happening in the automotive industry. That's that's what most people see, but in fields like material handling, it's actually prevalent and predominant in the industry. The electrification falls under the sustainability and allow reducing the carbon footprint. Electrical forklifts produce zero emissions themselves. There may be some carbon emissions based on the source of the electric production, but the machines themselves are zero emissions. So which make them an eco-friendly alternative to traditional fuel-powered models and allowing reaching corporate sustainable goals and regulatory demands adopted by most large organizations. The second aspect is allowed by the electrification is increased productivity and efficiency. Electric equipment has user-friendly controls, allowing operators to maneuver efficiently in very tight spaces and narrow aisles. Additionally, some models are equipped with advanced features such as variable speed control and programmable settings, enabling precise and automated movement. These capabilities save valuable time and reduce the overall labor required to complete tasks, ultimately maximizing the warehouse productivity. The third aspect is machines have better maneuverability. Indeed, batteries provide counterweights and allow for the machine to be more compact and maybe lower height, providing shorter turn radiuses for greater maneuverability in narrow aisles. The final aspect is that the electrifications enhance employee safety. This is due to the reduction of noise and vibration, as well as the elimination of fumes and contaminants in the air. With this advancement in material handling, the ergonomic enhancements that are done by most OEM, such as adjustable steering columns, comfortable seatings, and intuitive controls, are becoming standard features, which reduce the stress and the fatigue, and also the risk of injuries on employees. The electrification also is a key component for implementing automated machines such as AGVs or AMRs. Next slide. As we said earlier, material handling equipment electrification rates are some of the highest in the industry, and you can see here, even in recent years, the trend toward electrification and elimination of combustion engines is going very strong, and you can see the yearly evolution, which with the number of electric industrial vehicles continue to grow as battery charging technology and charging infrastructure develops. Currently, the rate of electrification globally, the rate of electrification in material handling is surpassing 72%, and this proportion is continuing to increase year over year. This makes the material handling one of the most electrified sectors in the industrial segments. In several jurisdictions, there are plans to completely ban combustion engines with diesel and propane, and replace them with zero-emission vehicles by 2030. Companies will continue to automate material handling equipment tasks to address the ongoing skill labor shortage in the manufacturing, distribution, and warehouse sectors. So this brings some enhancements, such as the warehouse management system that are being now deployed in a lot of places. These are software applications that help with day-to-day warehouse operation. These systems allow to control, monitor, and optimize the key functions in the automated warehouse. The second technology that is advancing is augmented reality that can be used to provide warehouse operators and drivers with real-time information and visual guidance to enhance their efficiency, accuracy, and increased productivity. With that, automated guided vehicles, known as HGVs, and automated mobile robots, known as AMRs, are rising in popularity, especially in distribution centers where there is a huge investment in robotics. These vehicles are using sensors, cameras, and advanced control systems. Their use can contribute to provide much higher effectiveness and cost savings. Machine electrification and the shift to lithium batteries are enabling positive transformation to optimize the use of warehouses and storage spaces in general. It allows for the efficient use of the space, optimizing the arrangement of loads and the use of storage space that can minimize the need for unnecessary energy wasting movement, greatly enhance the efficiency of the operation. It also allows, the trends also are for reclaiming the battery charging room. With the spreading of lithium batteries in material handling, the battery rooms are eliminated, or at least shrunk significantly, to eliminate like battery charging, dedicated spaces, as well as battery charging operation. So there are no more hazardous fumes that need special equipment to suck it. There is no acid splashing. There is no batteries to charge. So that all those spaces are reclaimed for allowing revenue generating activities in the warehouse. It's like you are extending the available space without growing outside the building. The last trend that we are witnessing in the material handling equipment usage is vertical expansions. And this is one of the simplest and most cost-efficient way to create new floor space for storage in the plant is to build up, not going out. So this has implications on the equipment. We have seen that more demand is going towards class 1 and class 2 lifting equipment that are becoming now are more affordable and effective solution that can be deployed to take advantage of the otherwise unused vertical space. Class 1 and class 2 equipment demand is growing higher than other classes of equipment. These factors will have impact on the vehicle design, on the batteries that are being used, and as well as the charging needs that are evolving. So let's talk about some of the changes that we are witnessing in battery technology. Lithium is spreading in different applications, replacing the traditional lead-acid batteries. Lithium batteries have an advantage, have a big advantage is they offer more flexibility when it comes to charging. Unlike lead-acid batteries, their life expectancy is not affected by the frequency that is of charging. This provides the opportunity to maintain the uptime of the of the work by opportunity charging the vehicles for shorter period of times. Lithium batteries have a cycle life, an expected life of between 2,000 and 5,000 cycles, depending on the application and maintenance. This means that the lithium ion battery will typically last 2 to 5 times or even higher, as long as compatible compared to equivalent lead acid batteries. The second advantage of lithium batteries is there is enhanced operator safety and comfort that are the result of more ergonomic vehicle design, because the batteries are smaller, so there is more flexibility in architecturing the vehicle, as well as implementing advanced safety features. And then the last one is the energy efficiency. So the lead, as explained by Marco earlier, the lead acid batteries lose capacity as when they are charging and discharging, like the cycles reduce the capacity. And it also they lose capacity when they are just sitting idle. Their voltage drop at an increasing rate once they start discharging, so forklift can be sluggish at the end as the shift goes on. Lithium batteries, in contrast, maintain a constant voltage throughout the discharge cycles, leading to as much as 50% energy saving compared to lead acid batteries. Among the benefits of lithium-ion batteries, specifically for material handling, is the ability to operate multi-shift applications. This reduces the numbers of batteries needed by using opportunity charger rather than having additional batteries that are being charged and then swapping them. The second thing is it allows for fast and opportunity charging. So the lithium can be charged anytime and topped off at ease for brief period of time, even like 5 minutes, 10 minutes, 30 minutes. That's fine. That's not this is in contrast with lead acid batteries that must be fully discharged and then fully charged each cycle to avoid long-term erosion of performance. This means that the batteries may be charged during break times or between shift rather than having a dedicated time for charging. This allows to save floor, as we mentioned earlier, by eliminating the battery rooms and the battery charging and changing rooms, and regaining that space for revenue-generating activities for the warehouse. Finally, the more power is available for bigger vehicles and heavier loads with lithium, because they are much compact, so we can electrify much bigger equipment. This allowed by the high energy density and the lower weight of lithium ion batteries, which make them very practical for OEMs to deliver equipment that can handle much larger loads, such as the big Class 5 equipment, and allow the conversion to electric powertrains, or providing a higher autonomy for automated vehicles, AMRs, and AGVs. These trends have been the shift from lead acid to lithium batteries have been happening in the industry, and as per like various estimates, we are sitting now around 50% usage globally, 50% usage of lead acid, 50% of lithium ion. It is expected that by 2027, 60% of the material handling trucks globally will use lithium batteries versus 40% for other technologies such as lead acid batteries. Within the lithium ion batteries, lithium iron phosphate, known as LFP, is the dominant chemistry. Indeed, this chemistry responds best for all the specific needs in the material handling sector, where excessive specific energy is not required, but there is a need for very high safety and long life cycle. The LFP chemistry are the safest and most stable on the market today, and are available in large capacity formats that are required by industrial systems. The life cycle in a battery with LFP chemistry today exceeds 3,500 cycles, and if equipped with a good BMS system, battery management system, it can easily surpass 4,000 cycles. Another advantage of LFP chemistries, besides its inherent safety and high cycle life, is that it has a flat discharge curve, which allows for the machine and industrial vehicles to guarantee the same performance from the beginning to the end of the discharge cycle. I'll pass it now to Marco.
Yeah. Okay. Now we speak about the charging technology trends. You might know that industrial chargers have to be selected depending on the application. And this is not difficult if we go to the old style, the ferroresonant or SCR chargers, which, don't take me wrong, they work very well, but they cannot stand the technology requirements of the rules, like I have stated before, and they cannot work with lithium. So when I speak about the industrial charger, I will concentrate on the performances, but I'm available for any question. So this slide that comes next is representing the industrial charger selection criteria, where you wanna follow this list in order to choose the best solution for your specific application. Remember, the choice is always application driven. In the picture, you might see that there is an onboard charger in dark blue and a stationary charger also in dark blue that are working together on the same machine. The onboard charger is going to be let's say, a standard charger for an 8-hour recharge time. The charger, which is stationary, might be a fast charger or a conventional, whatever you want to choose. But the size of the charger is typically made by the modular choice that we have taken with high frequency, because this technology allows you to use a smaller power module and multiply them in parallel to get the highest possible needed power. So what can you do with the high frequency chargers? You can control them properly, so you can analyze the charging time needed. You can change the profile and mode in order to stand the application need. You will respect the safety features and compliance required by the industry. You can choose, like I was explaining, on board or stationary, depending on the need. And if you have a charging room, you can also make remote control and cloud database analysis through the clouds that are available today. They collect data that can be used for calculations of state of health, of energy balance, energy usage, and shifts productivity, because this is the key point. You want to have the best productivity when you choose a fleet of trucks. You don't multiply the trucks. You want to have with the same truck the most movement of goods in the given time. And this is only done by a fully efficient performance of the truck with as less stops as possible for recharging, and the less consumption of the system as the fastest recharge time with the available new fast chargers. If we go to next slide, there is also an option which today is available. Here are the multi-voltage charging stations that are also application driven, but is is possible to use, and it gives advantage when there are not so many trucks by a company, and they want to simplify the connections and have just one charger type, so you can use a multi-voltage charger with the same different voltage trucks. There are some drawbacks. A multi-voltage charger typically might have an efficiency of the transformer that varies in the different voltages available. The safety of the system must be guaranteed, and I explain a little bit better. Lithium is safer conceptually because the battery is telling to the charger what voltage and current it wants. With the lead-acid battery, it is a bit more complicated. So the shake hands between charger and lead-acid battery is a bit more complex from the electrotechnical point of view. And using cloud-based is the solution for the future anyway. Then last drawback, which must be understood, the power stage of the charger must be sized for the highest current with power limitations. For example, a multi-voltage 80 volt 200 amps is 20 kilowatt at 80 volt. But if you use it for a 48 volt at 200 amps, it's going to be just a 12 kilowatt. If we go to the next slide, this is a concept which is we have been presenting, me and Morad, during all the chat, but it's difficult to calculate. So today we have systems that are more efficient, and this is a fact. But how do I choose my best efficient system? So I have to take into account different, let's say, experiences. I have the electrician that knows the net availability with the NEC rules, National Electric Committee rules in America, or with the European rules for the net. You have the limits of the sockets. We cannot exceed what you have available in the net. Then you have the charging efficiency, which was measured by the test I explained to you a bit earlier, and they are related to the energy in the charger and the energy out of the charger, which, if you remember, was ruled by California Energy Commission at higher than 89%. And you can measure it very easily. Then there is the charging efficiency. The charging efficiency is what you put in the battery as energy and what you download in discharge from the battery. It is not exact to say that what you will charge as energy will be available as discharge energy, because there are losses in the battery. And this is one of the major differences between lead acid and lithium. To recharge a lead acid battery, you need more energy than what you will have available after the recharge. With lithium, you are much more near to the real energy given and the real energy delivered to the truck. How can you control this? With correct charging algorithm and battery efficiency. So you need a good charger and you need a good battery. To measure what you deliver to the battery is easy, clearly measurable. If you have a battery that delivers current to the truck, you need to have a data logger, or you have to use an instrument that downloads the energy from the battery and measures it. Then the last system component which is the most important, is the truck. The truck is composed by battery, but also by motor, by controller and other converters. So it has a specific efficiency, which is related to its capacity, to the type of motor, and many variables that to be measured, you really need a data logger in the truck, because it is also application driven. So depending if the truck is heavily used, lightly used, uses a lot the pump motor with heavy loads in the battery, the energy that it uses is more or less, and depending on the choice of motors and controllers, you might be more efficient or less efficient. So this slide represents essentially what you want to do when you project a new machine. You want to have a complete idea of what is your target. Reach the best system efficiency. And all the new systems that Morad explained represent exactly this target. We want to reach the highest available system for this application available in the market. Next slide represents the battery room management. We have a system which is already fairly old because the cloud has been available since a while, but essentially you have a battery room artificial intelligence network. We call it BRAIN. It allows you to know anything that is in the charging room or any truck that is in recharge, what is the next truck or next battery to pick up as a driver. And with the data, you can make analysis graphs and understand the state of health of the battery or of the truck. One important piece of information is that it's not easy to make the calculations because there are too many data. But it is essential if you are a fleet manager to make this effort to understand if your existing fleet or charging room or let's say production lane of trucks and driving distances and layout of your facility can be unbettered. So if you need to really make an investment that in 2-3 years with the multi-generation product planning, you want to upgrade and reach higher performances, you might want to have a good cloud analysis of your existing fleet or make simulations with the existing companies that make system or solution providing services. As a group, we do this kind of service. There are other webinars that speak exactly about this, but I encourage R&D managers, machine designers, and the fleet manager or production manager to make some educated calculations on their possible recharging needs. It's our experience, but also machine needs or battery needs. And then I leave to Morad to speak about the, oh no, there is another slide which is important. Sorry, I was forgetting. Today, we haven't mentioned that the best match between special algorithms and hardware is high frequency with the correct software. So here in this slide, we represent all the technological improvements that have happened till today. We also show that there is compatibility between stationary chargers and onboard chargers, because what you see in the picture on the right is an onboard charger paralleled with 3 kilowatt power module to reach a 9 kilowatt power module that is able to recharge perfectly, exactly like a stationary charger, the battery. On the left, you can see an example of the graph where the current is yellow and the voltage is blue. And these are the most important things to manage when you recharge a battery. However, with these two values, if you see how many other values there are in this form, you might understand that the system is very complex. So you can really calculate how many watts you are recharging, how much it costs, how many hours you need to recharge. And based on this information, you might decide which charger to select. Next slide, I think, is still, this is a bit more technical. And what I wanted to show is that the stationary charger or onboard are at the same level when you speak about recharging the battery. So you won't have big differences. It's not like old bulky ferroresonant chargers or SCR that would not recharge the battery perfectly, or because of the network fluctuations, or because of the improper tolerance of the current or voltage. The onboard and the stationary have the very same approach and capability of recharging perfectly any battery. What are the differences? So to summarize, when you manage a charger, you have to look at the maximum voltage and current, and you need to find a safe operating area. And on board or stationary, they have the same way of controlling it perfectly. They both have a transformer safe operating area, and they can handle it very properly in the same way. What changes is the power stage safe operating area. And I have to tell you that is not a drawback. It's simply a different approach to the cooling of the system. Because the most stationary charger are fan cooled, you can really reach from -20 to +50 Celsius the very same exact identical delivery of current in all conditions. So your power will stay the same all over the charging cycle. Is it 2 hours? Is it 16, 20 hours? It's going to be the same. And you will suck the same energy, be small or big charger. This is another point which is very important. I will touch it later. The power stage SOA in an onboard charger is related to a temperature which is not only the ambient temperature, but is also related to the location where the charger is stored. So you might have differences depending on the truck, on the position, and of course the capacity of the cooling system of the charger to stand that temperature. What changes? Simply the charging time. So with the stationary charger, you might have exactly the time and calculate it. With an onboard charger, it might be more variable. Speaking about wattage and the energy that you load in a battery, is it on board or stationary? What drives the energy consumption is the ampere hour or the energy of the battery. One battery will always need the same amount of power when it is 100% depth of discharge, and you will pay always the same amount of money. You use a big charger or small charger, that battery will need that energy. So the message I wanted to convey is that the technology today is really a level where we can suggest and deliver to the customer the best solution.
A crucial component that might enhance the functionality and convenience of electrical forklifts is integrating an onboard charger on the vehicle. Onboard chargers offer convenience and flexibility, and that is one of the main advantages of onboard chargers. Electric forklift trucks equipped with onboard chargers can be charged at any location with a standard electric outlet. This eliminates the need to have dedicated charging solutions, fixed installations, and making it easier to integrate electrical forklift into existing operation without significant infrastructure change. This flexibility and convenience is also important for vehicles that are being leased or rented. It's very difficult, like if you are using an equipment for a short period of time, to invest into fixed installations. So more and more larger equipment, is like in class 1 and class 2, that have been used with fixed charger are now using onboard charger. The second advantage offered by onboard charger is reducing downtime. Indeed, onboard chargers facilitate optional charging, allowing electric forklifts to be charged during breaks and idle periods. This practice reduces the downtime and increases productivity, as the forklifts are less likely to be out of operation due to low battery. The third advantage is cost saving. By reducing the needs for expensive charging infrastructure, onboard chargers lower the initial investment required to transition to electric forklifts. Additionally, this allows for opportunity charging, maximizing the battery life and reducing the frequency of deep discharges cycles, leading to long-term cost saving on battery replacement and maintenance. The fourth advantage is the enhanced safety allowed by the onboard chargers, which are the onboard chargers are equipped with advanced safety features, including protection against overcharging, overheating, and electrical fault. The safety mechanism ensure the longevity of the battery and safeguarding the overall operation. The final advantage is the improved battery management. Modern onboard chargers are integrated with sophisticated control system that continuously communicate with the battery management system, especially for lithium. These integrations allow for optimized charging, extending battery life, and ensuring consistent performance. Another trend, next slide, please. Another trend that we see in the industry is more and more usage of wireless charging, especially with the introduction of lithium-ion batteries, as this technology allow for intermediate charging and allow for longer ride time. Wireless power transfer eliminate the need for a direct and physical contact between the batteries and the power sources that recharge them. At the heart of this technology, there is a charging pad or station strategically placed in high traffic areas within the facility. When a forklift equipped with the necessary receiver technology comes into proximity of this charging pad, the system automatically initiates the energy transfer process. The energy is transferred through electromagnetic resonance or inductive coupling. Energy is transmitted contactless from the charging pad to the forklift battery, efficiently replenishing its power level. The safety is paramount in industrial environment, and the elimination of charging cable, maybe charging pads that are exposed, minimize the risks of tripping hazards and accidents caused by this exposed wire. Moreover, the reduction in manual intervention reduces the chances of human error or people forgetting to charge the vehicles in regular operation. Fully automatic battery charging like this allows also, like, the advantage is to have a completely automated operation, especially of interest for auto-guided vehicles and EMRs. The automation and reliability enabled by wireless chargers significantly reduce downtime, allowing operators to focus on core tasks instead of managing the charging logistics. At the end of the presentation, here is what the important aspect that we would like you to remember. The regulation and user demand are changing in the industry, driving major transformation of the material equipment industry. There are technological advancements that are enhancing productivity, efficiency, and cost effectiveness of the equipment. The electrification is prevalent now in the material handling industry, with penetrations over 72% currently. The battery proportion is moving to is predominantly now based on lithium-ion batteries, especially lithium phosphate LFP chemistries that became the leading power source for electrical equipment in industrial environments. The evolving charging technologies are improving the vehicle performance, operation with high frequency chargers, efficient architectures, multi-voltage operations, and fast and opportunity charging. The cloud-connected chargers are becoming integral part of the warehouse management systems, Onboard and wireless charging are enhancing the vehicle productivity and flexibility, especially for EMR and AGV operation. And that you have to keep in mind that for OEM producing vehicle equipment, that the choice of the power component suppliers is crucial for the success in the marketplace.
So before we go to the live Q&A session, I just wanted to talk a little bit about our charging solutions at Zappi Group. So Delta Q and Z-Van both offer a wide range of lead acid and lithium ion battery charging solutions from 350 to 36 kilowatts. Delta Q and Z-Van were both founded in 1999 in Canada and 1985 in Italy, respectively. And our range of battery chargers are designed for easy integration with other Zappi Group solutions and our battery partner network. So with that, I would like to now open up for the live Q&A session. If you haven't already, while we are answering some of the other questions, please submit your questions in the Q&A tab, which you can find to the right of your screen. So one question that we've had is, in many cases, the LFP battery manufacturers offering their own battery charger together with the battery, in which cases it can be not the better choice for the final users.
Generally, lithium is a good solution. However, the vehicle itself, like for example, if it has lead acid, moving to lithium because they have lower weights and because of higher energy density. So the vehicle needs to be somewhat redesigned to redistribute the weight within the vehicle. So there is some design that are needed for the vehicle. It's not just moving it on by so it needs adding some counterweights. So that's one of the advantage. The only still a little bit downside of the lithium technologies is the cost, is the initial cost for acquiring the technologies. But other than that, is lithium is much better than lead acid solutions.
Awesome. The other question that we have is, how long battery cycle life has a heavy EV trucks, EV buses, and lifting cars?
That's
long.
a question.
Yeah.
Yeah, that's a question that is not precise enough. I'm sorry. What life is related to the application, and this is related really to a standard which is tied to the vehicle. So for a bus, they might design a battery that will last longer, and for a car, different. So here really we need to stick to a precise vehicle, and then we can answer.
Okay. The other question that we have is, would you please inform which is the efficiency gap between conventional charge and high frequency, and which is the main benefit of using constant power charging device?
Okay, I can answer to this. So traditional chargers range from 50 to maximum 75% efficiency. They are good chargers, don't take me wrong, they work very well, but they cannot reach the efficiency of an high frequency charger. So there is minimum a 20% gain in the choice of using a high frequency charger, but you can really go higher than that. And sorry, what was the other part of the question?
The other part was, and which is the main benefit of using constant power charging device?
Okay, constant power and constant current. These are two concepts that are confusing most customers. Constant power was the old way of the Ferros. They had a transformer, a bulky one. You put 480 in it and you get 24. It was just a ratio of the coils that delivered the DC from the AC. If you had variation in the AC, you would have had variation in the DC and therefore an improper recharge voltage and current. That was the old constant current. You probably remember all the chargers were called WA or WO, WA. They had the second one at 2-stage of transformer ratio. However, constant current is the one you can really do with SCR, which is still old technology, but they can do it, or with high frequency control charger. Constant current is a very easy way of delivering a current that you can calculate in order to find the charging time, but you can also make a smoother recharge, and you can really wait until the battery reaches the correct voltage. This happens both with lithium and lead acid. So you might want to go to constant current recharge in many applications. But if your charger is, let's say, a 3 kilowatt, when you are at the beginning of the recharging cycle, your constant current multiplied by the voltage at that time will be lower than 3 kilowatt. So what are the manufacturers of chargers doing? In the first part of the recharge cycle, when the battery voltage is lower, they make the constant power. So the value of the multiplication between the voltage and the current is always 3 kilowatt. This is the constant power mode which is used by most manufacturers. With a stationary charger, it is up to 2.4 volt per cell for lead acid or whatever is the lithium value, which might be 3.65 or more volt per cell, up to 50 degrees. With onboard charger, the concept is the same, but it is in relation also to temperature, because depending on the temperature, there is a derating which is necessary to keep the charger alive and last all the expected hours of life, because electronic life is tied also to the temperature of activity.
Okay, so we have our one last question before our time is up. What are the power output available for onboard chargers?
Yeah, traditionally, onboard chargers were limited to, let's say, below 1.2 or 1 kilowatts. But advancement in technologies in companies such as Zivan and DeltaQ push the limit. So now for onboard chargers, power level are available from as low as 350 or like 100 watts all the way to 20 kilowatts. So solutions on board and I'm talking here for low voltage applications that are predominant in material handling. So voltages below 100 volts or below 48 volts. So we have solutions. There are solutions, solid solutions today in the industry to go up to 20 kilowatts onboard charging, and anything in between. The systems are scalable, so you can have the right power for your application.
All right, everyone. With that, we will end this session. And I want to thank you both, Marco and Murad, for an insightful presentation. And I would like to thank all the attendees for attending and asking such a great questions. You can now go back to the lobby to attend the other sessions. And if you wanted to see a copy of the recording, this will be available once we stop broadcasting. Thank you all and enjoy the rest of your day and the rest of the conference.